Welcome everybody. My name is Boris Scholl. I'm a program manager on the Azure Compute team. Within the Azure Compute team, I'm working on Azure Service Fabric, which is our platform for building microservices. In particular, I'm looking after container integration with Service Fabric. I'm here today to talk about Microsoft Azure for developers and DevOps. So out of curiosity, how many of you have seen Azure? All right, quite a few. So how many of you have never heard about Azure? Nobody, good. So with that, let's jump into the agenda. When you have looked at Azure, you've seen we have a lot of offerings for developers. So what I'm going to cover today is really our compute stack. Our compute stack is basically the foundation for all of our services. So I'm not going to talk about our IoT suite, and I'm not going to talk about our media services. But what I'm going to talk about is like how our compute stack is built. Then I'm going to start with Azure Virtual Machines. How many of you have used Azure Virtual Machines? Okay, spend a little bit of time there. Then I'm going to cover Azure Virtual Machine scale sets. How many of you have heard about scale sets? Cool, I got something new. So we released that actually a week ago. Then today, we also released our Azure Container Service this morning. So you're going to be the first one to see that thing live. I'm going to cover the Container Service. And then I'm going to spend some time on Azure Service Fabric with a bunch of demos. And then if time permits, I'm going to talk about Azure Web Apps. Sounds good? All right. So let's start with our what we call next generation cloud platform. So it's a very simplistic diagram, but I hope it gets across like how we basically build our Azure platform. So at the very bottom, there's Azure Stack and Azure Public Cloud. How many of you have heard of Azure Stack? Okay, so for those of you who haven't, Azure Stack is our on-premise Azure service. It's literally identical to what you have in public Azure, and you can deploy it to your private data centers. It's exactly the same thing. And then Azure Public Cloud obviously is Azure. So on top of that, we have virtual machines and VM scale sets. And as I mentioned, VM scale sets are absolutely new. And VM scale sets are really great for providing a foundation for PaaS-like systems. So that's why Cloud Foundry, we announced a partnership there, is basically built on VM scale sets. You can run Mesos as a cluster management on VM scale sets. There's a bunch of other PaaS solutions that just run on our scale sets and virtual machines. Then on top of virtual machines and scale sets, we have what we call VM extensions. VM extensions, you can think about, it's a very, it's basically a service to customize your virtual machine once it's been provisioned. So think about you want to add some software to it, and I'm going to cover that later. So on top of those extensions, we're going to have the Azure Container Service, which I'm going to show later. Which is basically like, we had a panel discussion yesterday about microservices and containers. It's basically like an orchestration based on Mesos with Kronos and Marathon as the schedulers for containers. Then we have our own Azure Batch service, and then we have Azure Service Fabric building on top of it. So Azure Service Fabric, the reason why I put apps and containers in there is because Azure Service Fabric is also an orchestrator and cluster management. But the biggest difference to all of our other Azure offerings is that Azure Service Fabric runs anywhere you want. So you can put it on bare metal, like on a Windows server. Soon we're going to be on Linux. You put it on Linux servers in your data center, and you can even put it on other cloud providers. So on top of that, we have like those vertical solutions like media services, app services, and app services, you can basically build web apps and mobile apps, and then we have what we call Service Fabric applications. And those Service Fabric applications basically take advantage of our programming models, actors, and reliable collections, and I'm going to touch on that. So before I'm going to talk about virtual machines, we need to cover one important thing, that's the Azure Resource Manager. How many of you have heard about that thing? Okay, so think about when you deploy an application to any environment, it's not Azure specific, right? Your application is not just a website. It's not just a database. Your application is actually a collection of multiple services, multiple products. And so far, if you basically use scripting or anything else, it's really hard to have like a logical container for those type of applications that groups everything together. So then you can deploy it at once. It's one single unit. You can update it. You can have billing on it and everything. Right? So that's why we introduced Azure Resource Manager. And Azure Resource Manager is really what we think about as an application lifecycle container. You basically specify, and I'm going to talk a lot about that, a JSON template that describes your environment. So for example, it has a storage account in there, it has a virtual machine in there, it has network interface cards in there, and so on and so forth. So it's a declarative way, so config as code, basically, that you can then also put into source control. The thing that I mentioned before with Azure Stack, if you use Azure Resource Manager, you have a consistent management layer because Azure Resource Manager is also available on Azure Stack. That means if you have your on-prem environment with Azure Stack and you have your public Azure environment, you just need to define your environment once as an Azure Resource Manager template, and then you can provision it to either your private cloud or your public cloud. Another core concept of Resource Manager is a resource group, and that's really the logical unit of your application. A resource group, every resource in Azure has to live in a resource group. And the resource group is basically the container for everything. And the picture on the left-hand side shows it very nicely. So you would basically create a resource group that has your database in there, that has a website in there, that has a virtual machine in there. So in this resource group becomes your unit of management. So you can deploy all those resources together. You can update them together. You can delete them. Also, what you can do is you can assign permissions to those resource groups. So think about you build solutions in your enterprise where one department wants to have that service running and another, or that application running. Another department wants to have another application running. So you can assign permissions to those resource groups based on departments. So you have a very good way of controlling access to those resource groups. And then, on the other hand, on hindsight, with that access control, you also get a very good support for billing, metering, and so on and so forth. You know exactly how much money, compute hours, storage hours, transactions were spent by a certain resource group. And in that sample that I was mentioning, you could actually cross-charge it back. So now you may wonder, hey, this is great, but what about I already deployed an application using Azure Resource Manager, and now I add a new component to it? Is it going to wipe out everything? Does it take long? What's going to happen? What's happening is Azure Resource Manager is actually idempotent. So you would just add that resource to your Resource Manager template, let's say a new website. You would deploy the application again, and then Azure Resource Manager would figure out, hey, I already have all the other resources there. I just create that website. It's also a good way for simplifying orchestration, rolling back things if something went wrong. And you would also use it for gross resource group coordination. So Azure Resource Manager templates, and I'm going to show you one in a second, is actually, as I said, it's like JSON files. You can check them in. You can treat them as source code. You can check them in along with your applications, its version and everything. But more importantly, it also allows you to declare dependencies. Because, for example, you want to build a website that needs a database, a certain database. In that Azure Resource Manager template, you can actually declare, hey, that website needs that database, and if the database isn't there, it will throw an error. So you can actually declare dependencies. Also make sure that certain prerequisites, other services are there before you provision another one. So with that, let's look at the first thing, Azure Virtual Machines. We think about Azure Virtual Machines, and a majority of you have used them, so I'm just going to skip over that. Has two building blocks. The first one is the operating system itself, that's in an image, and the data disk images. Our virtual machines come in different sizes, shapes and sizes, if you will, so you can basically pick and choose which ones are the best for your workload. Then from a Windows base OS perspective, we not only provide Windows Server images. If you have an MSDN account, you can also provision Windows Client images. That has been quite popular with our customer base because they can actually have developer desktops in the cloud, or they can test applications in the cloud on Windows Client images to make sure that application behaves the same way for dev test scenario. Then obviously, we now support a huge variety of Linux-based OSs, and we're really happy to do this. And now, lately, we just announced our partnership with Red Hat, which we're really happy about, so you can run Red Hat Linux machines on Azure. And then we also offer Azure certified images. That's, for example, we have a partnership with Oracle. We have lots of partnerships, right? And Microsoft, or some of the Microsoft divisions, work with those partners, build those images, and make those images available to you so that you can just provision them. And when you use those Azure certified images, you can be sure that it's working, and you can call support. And then we have community images. Community images is actually also a very great thing in our marketplace, because if people want to build their own virtual machines, and as a developer, you put a bunch of tools on it, right? And say, hey, I need Fiddler, I need whatnot on a machine, and I just take a snapshot. You can make that image basically available to others, which is really great. So then I was touching VM extensions, because if you use a shelf image, what we call a shelf image, let's say a Windows Server or Windows Client image or a Linux image, it has nothing on it, right? It's just the OS on it. So in Azure, we have a thing that's called VM extensions that actually allows you to add software to the virtual machine after it was provisioned. And we have a bunch of extensions. So the most popular ones are obviously security ones, because people want to do virus scans. They're concerned about security. So we have our own one, but we also have semantic and trend micro images, VM extensions. We also have a variety of deployment extensions, and that's actually also good. Think about a dev test scenario, or think about you want to enforce a policy, right? So people in your organization provision virtual machines, and you want to make sure that that virtual machine gets a certain piece of software or a certain configuration that's mandatory in your enterprise or in your company. You can do that by using things like Puppet, Chef, recipes. You can have custom script extensions and so on and so forth. And then it will make sure as soon as the virtual machine is provisioned and the extension is applied to the virtual machine, it will basically pull down those type of things. And again, we support a lot of things like Chef, Puppet, Octopus, like all the popular ones. If that's not good enough, we have a lot of scripting extensions. So you can write your own scripts and basically have script hosts on Linux machines. You can have DSC scripts on Windows machines and so on. So you get a very good configuration experience there. And then we have a bunch of others. So for example, if you are currently still in the .NET world and you use your Windows images or your Windows virtual machines for dev test purposes, and you want to debug your application, you can just apply our debugger. It's working from Visual Studio. You can apply this. Then various diagnostics agents and monitoring extensions, access recovery. Docker is a very popular one that we have, and backup helper. But to summarize this one, like a virtual machine for us, it's really like we think about it, okay, we give you a bunch of base images. You have also access to a lot of partner images. And if you want to customize your image, your virtual machines, we give you a lot of tools to do that. So that was a lot of slides. Now let's have a look at the images, because I was talking a lot about JSON templates, and we all know JSON is so much better than XML, and everybody can read it, right? And it's great. So now you say, oh, Boris, JSON templates, that's probably hard for me to get started with like virtual machines in Azure if I need those to provision this. So the good thing is, what we have, and it's open source, it's actually, everything's open source. Like it's Azure Quick Start templates. We have a gallery up on GitHub, and that gallery has, I don't know, it's like growing on a daily basis. A lot of templates in there, resource manager templates that get you started. So for example, let's say you want to create 2 virtual machines behind a load balancer, right? Before you actually think about, oh, now do I need to learn that JSON, and how does that work, and how does that JSON file look like, you can go to this gallery and you'll probably find it, because we not only have like the very simple ones, hey, show me how to create a virtual machine, or show me how to create multiple instances, and so on and so forth. We actually have ordered it based on difficulty level. And then we go down to 200, and then if we go all the way down, you can see oh, I want to deploy DataStax Enterprise, Cassandra. I want to build a Cassandra cluster. How do I do this? You just go there and you click the template. And let me show you one that I already picked. So this is a quick start template for 2 virtual machines and a load balancer. And if I look at the JSON file here, this is actually the JSON file. So it starts with a bunch of parameters that you want to put in there, like what type of image do you want to use, how many instances, and so on and so forth. Do you want extensions? Which region should that virtual machine be deployed to, and so on. And then down here is what we call resource providers. And let me just scroll down there. And net rules. Here's the resource provider. This is actually the section that defines the virtual machines, right? So we say, okay, it's a Azure Compute resource, virtual machines, and here the important part is, and that's where I want to draw your attention to. We have a thing that's called resource loops. So if you want to create multiple instances of those, you basically create a resource loop and say, okay, I want that many instances. So this is basically the JSON template. But it gets actually better, because if you think about it, you want to deploy it to Azure, we have this nice deploy to Azure button everywhere. So that opens our portal. This is our Azure management portal. And it actually opens the template. If I'm already authenticated because I did it before, so my token is still valid. If that wasn't the case for you, you guys would probably need to authenticate. But here, the key part here is I have the template is basically open, and if I wanted to make changes to that template, let's say you like a base template, and that's always a good starting point, right? You pick a template from GitHub and say, this is very close to what I want to do, but I want to make some changes. You can actually go in here and edit a template in here, save it, and then just provision it. So I discard that. From a provisioning perspective, it's very, very easy. You just enter a bunch of parameters here. It's like my password. And then there's all those things you need to put in there, like, for example, demo1, my VM, I leave it. So there are smart defaults. And then you basically just hit OK, and you start provisioning it. So what that thing does now, it just goes ahead and provisions 2 virtual machines with a load balancer and net rules. Very, very easy. Started from GitHub. Very, very efficient for developer scenarios or even like for production scenarios. So I already done that. Let's go back to this one. And because obviously the provisioning will take some time. It's not. So this is, I deployed exactly that template before, and that's actually what I get. After probably 5 minutes, you have a completely configured environment. That environment has availability set. So this is actually here. This is actually a resource group, what I was mentioning before, and in that resource group, there are all your resources. So everything was deployed in one resource group, and that's what you exactly see here, right? And now you could even tag that resource group and say, hey, that's my dev environment, or that environment belongs to department A or department B. Very easy to do that. So from a developer perspective, that's great, starting there, but a lot of developers also like to work in Visual Studio. So in Visual Studio, if you use, how many of you are actually using Visual Studio? Oh, quite a bunch, okay. So in Visual Studio, if you have installed the Visual Studio, I think just Visual Studio that works for the Azure Resource Group, you have a new project entry or project type. It's called Azure Resource Group. In that project type, you select this one, and what it does is it gives you a starting point of what we think are good images for you as a developer to get started, right? So you can basically pick it here. So we have virtual machine scale sets, service fabric cluster. You can see this mostly our Apache stuff where we want to do stuff. We also have a Docker image because we also have Docker tools. So you can basically create a Linux VM with Docker on it and then use our tools and just deploy right into the create a container and basically launch those containers. And then if you have already a JSON template, you can basically just use a blank template and fill it in. Why I'm showing you this is because this Visual Studio has a great way of showing you the outline of the JSON, because that's always pretty hard, especially if your JSON or if your resource manager template gets fairly big, you have a lot of resources in there and you want to navigate. So that project type here actually created a template, and here's the virtual machine JSON file. On the left-hand side, I have the outline view. And if I'm going to go into the outline view, similar to what I've shown you in the portal, you see actually what kind of resources are in that template. It even gets better. If you select a resource, it actually highlights the resource, and it has IntelliSense and things like that. This is a virtual machine, a plain virtual machine. Let's say you want to add a DSC extension to it because it doesn't have it, right? So you go in here and say you want to add a resource. And as you can see, we have a lot of resources in here. Again, starting from SQL Server, SQL databases, Redis cache, you name it. In that case, I want to just create I just want to add a DSC extension, because remember I was saying our base images are plain. There is no IIS installed. There is no web deploy installed to push up a web application or anything like that. So in the Windows world, you would probably do this with a DSC script, right? So in here, you could say DSC extension and say my DSC, and then add it to the template. And as you can see, it's highlighted. I could make changes here. But what's more important is we also, in Visual Studio, we create a folder for you. It's called DSC. So the DSC script is in there already, prepackaged. And then we tried to be really smart and added a bunch of DSC commands to it, where basically if you just comment on those sections out, it will configure IIS as a web server for you and deploy and add the web extension to it so that you could just deploy web applications into it. And then in order to provision the environment, you just go here and say deploy, and then new deployment. It would realize your account, and then you can basically create a new resource group, choose an existing resource group, and deploy the template into it. I think that makes it really clear why this is actually not a bad way to work with resource groups, because if you have code like .NET code, Node.js code, you could actually put all that stuff in the same solution, and you could basically source control it and everything. Okay, so this was a very quick view of virtual machines, Azure Resource Manager templates, and how to best work with it. Let's go back to the slides. So let's think a little bit about the challenges of virtual machines, what I've shown you. So what I've shown you is, that's why I picked the template with 2 virtual machines, and I showed you a resource loop, right? So I had to create a resource loop for my virtual machines. And I need to do that for literally every resource that I need to double. So for example, a virtual machine is not just your virtual machine, it also has a network interface card, right? You probably also want to have a different storage account for it, maybe not. Or you want to have a different load balancer rule for it, and so on and so forth. So you would need to create those resource loops pretty much for every single resource there is in your template. I mean, you could start from that. But that's a little bit of a problem. It works very well, but I mean, if you have a lot of things, maybe you just want to have identical VMs, then you don't want to do this. So then for virtual machines, really, there is no easy mechanism to scale in. Like once you have a bunch of instances, how do you take them away? How do you make sure those things are still available and are best balanced between like upgrade domains and fault domains? And the same thing applies for scale out, right? And the thing is, for resource loops are great, and we use them a lot, but they're just a syntactical shorthand for basically making things really easy. But in the background, we do a lot of calls into Azure, right? Because every loop creates a new resource and so on and so forth. So provisioning time really takes quite some time, right? To basically build out 5 VMs. And if you have 5 identical VMs, you probably just want to define it once and say, okay, I want to start with 1 instance, and then if I have a certain load, I just want to scale it out or scale it back in. Right? I don't want to deal with all this network interface cards, loops, and so on and so forth, because I literally have identical VMs. And this is where really our VM scale sets come in. And again, that's very new. So what are virtual machine scale sets? It's basically a way to deploy and manage a set of identical VMs that I already mentioned. It automatically integrates with Azure Autoscale. So the virtual machine really is infrastructure as a service, right? You literally need to do everything you do in your on-prem world, right? Except you already have the hardware, but you need to define network interface cards and so on. So you would also need to integrate with Azure Autoscale. Scale sets, it's already integrated. It's also integrated with a load balancer. So you don't need to define load balancer rules for every VM, because if you just have a single VM, you create a new instance, you probably need to make that thing available to the load balancer, you need to create a new probe, and so on and so forth. That's all it's all built in for you. It's its own resource provider, so it's good you can actually set permissions and stuff like that on it. And then what it really is, and that's why I was showing the diagram at the very beginning, it's a scalable compute layer for hyperscale apps where you need to have that dynamic scale on the virtual machine level. You have an application running that receives load and you want to scale out and you want to scale back. That's really what it is. And in the end, this is really like an infrastructure for platform as a service. So how does that work in Azure Resource Manager? So I have a resource group. In that resource group, I basically have a virtual network and a subnet. And then my scale set resource provider is really everything I define. I define a resource provider, a scale set resource provider. I say I want to have that VM type, number of times. And then you basically have those network interface cards or storage accounts or extensions just as part of properties, right? So it's not that you need to do this on a resource by resource basis. You really just have it as a property. And that's why you have a unit. So this is really great because, as I mentioned, it's auto-scalable. Everything's integrated. It's super fast because as it is one call, we just make one call to Azure. So if you need to spin up like, I don't know, 1,000 instances, it's really fast because it's not like going through loops over and over again, right? It's super customizable, so you can create VM scale sets with Windows machines as well as Linux machines. You can even bring your own images and say, hey, I want to create my own images, scale set with my own images. You can apply all the extensions to it that I've shown before, your own, and it's basically like an open path platform. So what it really gives you is ease of management. Let me show you scale sets. So let's go back to my favorite tool here, which is GitHub. So on GitHub, we have what's called VMS Lab Stack Autoscale sample. And that's actually, I would encourage you just look at that sample and play around with it. I'm going to show you how it works. But this gives you a really good feel of what a scale set is and how it behaves. So what this particular thing does is it has obviously the template itself. And if we look at the template here, going down here, storage account. Here's the scale set. Here's the scale set resource provider, and I basically say, okay, upgrade policy, virtual machine profiles, what kind of virtual machines, and so on. So it's way. I know it looks hard, but it's way easier to create than the other ones. But what's key on that one is if we go down here, we have diagnostics. We have those auto scale settings, right? And they come with it. And here we say, okay. You know what? When my CPU threshold is at 60%, scale out, right? And likewise, we say, if it goes down to 50%, scale in again. Very easy. And what that sample really does is, it's using a do work PHP app on Linux. And when you deploy that sample, which I'm going to do now, deploy to Azure, so this is always the longest part because it authenticates. So, but then in here I could also do all the same things that I've done before. And here I basically say resource location, I want to have it in a West US, VMSQ, I'm going to use the standard one right now. My Linux version, VMS name, call it VMSS demo. Instance count, let's say I want to start with 1, and then I'm going to add my admin username, call it this one, and then add a password. And then I hit OK, and that's pretty much it. I mean, I would need to create a resource group, or I can select a resource group that's already there. I mean, that's self-explanatory. So I'm not going to hit OK now because I've already done this. If I go to the app, that's actually the app that has been deployed. Very easy. And you can enter some durations in here, how long it should create load. In here, it's basically let's say 100 seconds. Do work, and now the app starts like putting a lot of load on the virtual machine that I created because I have only one instance. So I can assume my CPU goes up, right? My CPU usage goes up. So let's go back to the portal here. All right, so as I mentioned, I already pre-provisioned it because that takes a little while. So in here, I have my scale set. And if I look at my VM scale set in here at my resource provider, I'm currently running at a capacity of 1 because that's actually scaled down again. But over time, you would see that changing. And just to make sure I'm not telling you something, if I look at the logs here, so those are basically the logs we added in there. You could see, I've done it right before we started the session, but you can see once the load increases and once it hits the threshold, it actually scale up in that sense. So it adds more instances to it. As long as or until the load is leveled, and then once the application stops, it basically scales it back automatically. So that's really hard to demo. I hope I got it across because I would really encourage you just go there and try it yourself. But the takeaway is it's really easy to configure. You get a set of identical VMs. Everything is wired up for you. You don't need to configure a lot of things, and it really dynamically scales out and up based on the rules you set. Those are scale sets, and the next service I'm going to show is actually built on scale sets. Let's go back to the slides. So the next one is really the Docker or the container service. So let's talk a little bit about our Docker integration first. You've probably heard, how many of you have heard about our Docker partnership? So yeah, my boss, Corey, is really vocal about this, and we're really happy. So we're not only supporting Docker on Linux VMs, right? We really have a close partnership with Docker. So we also build containers on Windows. How many of you know that we are building containers on Windows? All right. So we have two types of containers. The first one is what we call a Windows container, and the Windows container is identical to a Docker container in Linux. It's exactly the same thing. It has the same resource boundaries, everything. It's exactly identical. The other container type we're building, it's called a Hyper-V container. And the Hyper-V container you would probably want to use if you build a cluster or an application that hosts multi-tenant applications. Because while Docker containers give you a really good isolation, for a I'd say multi-tenant application, they still share the same kernel, so you provide some sort of attack surface, right? With a Hyper-V container, it's actually a very, very lightweight virtual machine that has its own kernel, so you don't have that common attack surface, and it runs isolated, truly isolated. So we have Windows containers, Hyper-V containers, and then the Docker containers in Linux. But what we do is we didn't, like in the past, Microsoft would have just their own thing, right? We would have just done our own thing and said, hey, yeah. No, we didn't do that. We actually work with Docker, and our containers, they also, or our Windows server contains the Docker daemon. So that means, in hindsight, you can do everything you do with Docker on Linux with our containers on Windows. So you can use the same tools, you can use a Docker client and everything. It's exactly the same, right? So this is the Docker integration, but now thinking about it what we discussed at the panel yesterday, right? Just spinning up a container doesn't give you much, right? So what you really need to do is, let's say you have one service per container, you really need to spin up a bunch of containers amongst the cluster. Let's say you have, because you want to make them highly available, right? You want to make them resilient. So you need something that actually manages your cluster, because one virtual machine, or literally one virtual machine, doesn't give you any high availability, right? So you need a bunch of them. And then you need something that actually spins up or schedules the containers on that cluster, right? So it says, okay, so how many resources has this virtual machine left? Okay, I can place a container there. I can place a container there, right? So what we've done is we basically built an Azure Container Service, which is also based on VM scale sets, and it's available on Windows Server virtual machines, or Windows Server, and Linux, because we support like containers in both worlds, and we use the same mechanisms. The key part of that container service is really, that's a true open source container service. There's nothing Microsoft has done that's different from what's out there in the open source world. So everything that thing does is it just makes it super easy for you to spin up a cluster using Mesos, which is a very popular cluster management framework. And then we give you a bunch of orchestrators on top of it. So we provision out of the gate, we provision for you Kronos, Marathon, or you can use Docker Swarm. So and there is no magic that Microsoft has done. It's literally, it's very important. It's very open, and you can do whatever you want. So for example, for monitoring, you can put AppDynamics on it, right? You can put like all the tools. It's yours. You can do whatever you want there. The only thing we've done is we've really made it easier for you to spin up a cluster and have a container orchestrator on top of it. So with that, and that, by the way, that was just announced this morning. So that's very, very hot off the press. So let's look at the container service template. So the container service is still in private preview, and the slide deck has a link you can sign up for if you want to play around with it, because we basically whitelist your subscription. But so here's the template, and again, it has a it basically has a JSON template, and then you can go in here and just deploy a container service with a Mesos orchestrator and Kronos and Marathon frameworks. And you can do this with a chunk box or without a chunk box. Chunk box means you have like a VM you basically remote into, and then you talk from that VM, you basically talk to your container service. Or you don't have that, and if you have Linux, you basically SSH into every single VM that you create for a container service. So let's create one, or let's show how you would create one with a Windows chunk box. So again, I'm gonna get to the portal here. And then we have just a few parameters to fill out. This is actually a good use of add a template, because what Ross did, the PM who owns that, he actually hard-coded a username for the RDP, so you probably want to change that in there. But long story short, you go in here, you fill out a bunch of parameters, you add your admin password, the DNS name, and then you have the agent count. The agent count are actually your virtual machines, right? How many machines do you want to have containers run on, right? And then you have your master count. And how many of you are familiar with Mesos? Okay, so Mesos is basically like open source. It was originated from Aurora. I think the Twitter guy started it. But it's a very popular cluster management solution. It's actually the most popular one out there. But what it does is it creates a cluster, and a cluster is a collection of machines. Let's say a 5-node cluster means you have 5 virtual machines, right? And then you have a thing it's called Zookeeper, which is basically responsible for your leader election. Because now think about your cluster, one node goes down, one virtual machine goes down, someone or something needs to decide where to direct traffic to or where to rebalance the resources to, right? So that's why they use Zookeeper for leader election and say, hey, one node went down and the other nodes report back to Zookeeper and say, hey, this node is not there anymore. Then they have quorum and they say, okay, we exclude that from the cluster. But that's why you need to have a master count, because you also need to make Zookeeper highly available. So, and you would probably do that with like 3 instances. That's why it's the master count here. So as you can see, like setting up manually setting up a Mesos cluster with Zookeeper and Marathon framework is a lot of work, right? Because you need to think a lot about things. It's not free lunch, and that's what we were talking about yesterday at a panel, right? It's complex. It's not just your container. And so the container service we built here really makes it easy. So let's assume I have filled out all of those things. What I get then is the container service. Here I call it BMS ACS. And this container service is actually like provision a bunch of resources, because I have like 3 leaders or 3 masters and a bunch of virtual machines and so on and so forth. So it's a fairly complex topology, but that's a very typical topology for a Mesos cluster with VMs on it. So I also have a chump box, and my chump box is, I'm remote desktoped into the chump box, and that's where we make it really easy. So you've seen I just entered. You just need to understand the concept of the master and like the instances, right? And then we provision that for you, and then if you use that chump box, what we do is we already set up Mesos for you. We configured Marathon for you. We configured Kronos for you. If you choose Swarm in the GitHub repository, we create a Swarm cluster for you. So now I'm in my chump box, and I'm talking to my Mesos cluster here, and my Mesos cluster has a bunch of active tasks already. So just to show you that I'm not lying, so there is the Kronos UI, and as you can see, it's beautiful. No, it comes back. So this is basically the Kronos UI. That's your scheduler, where you basically say, hey, I want to run a bunch of containers, right, or a bunch of applications. That's what you define in here. And we have the same thing for Marathon. And Marathon, this is the UI for Marathon. Let's do a little thing here and create a new application. And call the application simple web. I'm going to give it like 256 of memory. And then I want to run a Docker container. And I'm going to run this Docker container and call it simple web. And I'm going to use the network host. That basically says it should use the host network, basically the mapping. And then I'm going to go in here, scroll down, and I have some optional settings because we also expose port 80. And then I'm going to hit enter port 80 to this one. And then I create the application. What's happening now is, so basically, Marathon starts pulling down the image, and because I've done it before, it's very fast. It goes out to Docker Hub, or it actually looks at the machines, executes a Docker command. It's a Docker pull. Docker pull notice, hey, this image is already there. That's why it's really fast to start the container. So now it launched a container on my Mesos cluster through Marathon. Very easy. You can set that up with any other tool. So let's see what that thing does. If you go in here, that's the IP address of the container service. Then you can see it's a very nice image for demoing. You basically see the requests coming to the URL, and you can actually play around with it, and you'll see it will basically count it up. So with that, very few clicks, we created a cluster for you, like a container service cluster based on Mesos with Marathon. And it's actually a really good thing, especially how many of you are interested in containers? So the majority, right? So it's actually a really good thing to learn about it, because you don't need to worry about all that setup first. It's really, you can get your feet wet very easily by just using the template, setting it up, and then you can play around with it and make yourself more familiar with it. Again, private preview, just sign up. There is a link, and then I will give you access to it. All right, so let's spend the last couple minutes on Azure Service Fabric. So how many of you went to the panel discussion yesterday? Okay. So yesterday we had a discussion about like what is a microservice, right? The way we usually look about it is, okay, what's a monolith versus a microservice? And this slide is supposed to show you this. So in a monolithic application, you basically build one huge block, and your componentization was based on components, DLLs, and so on and so forth. To scale out an application like that, you basically created a new instance of that application and put it on another VM or other machine or even another container, right? So that's how you scale it out. Microservices world, if you look on the right-hand side, it still has the notion of an application. That's like the dotted line around it. But that's really more like it's more like a concept, because what makes the application are the services inside, like those little circles there. And there is no application per se. And now if you want to scale that out, what it does is it deploys the applications into your cluster on different nodes. So the cluster concept is distributed computing, basically. You have a cluster, just like with Mesos, and it deploys it on the nodes based on availability, resource availability, and so on and so forth, right? So that's the biggest difference. You don't have an application running on a box, right? You have a service running on a box. And with that, it's independently updatable. You can basically just update the service. You don't need to bring down your application, right? You just deploy a new version of the service. So what is a microservice? There is like a bunch of definitions, but I think like leading industry experts have agreed on, like it encapsulates a scenario, like usually it's centered around a business scenario. Developed by small engineering teams. The good thing is it can be written in any language and framework. So you don't need to trim your entire IT organization to learn, let's say, .NET or Node.js, right? So your developers can really use the tools and the languages they're used to and they're good at, and basically makes you more efficient. And then it's also a very different thing. It contains the code plus state. So in a Monolith application, you had a database, right? Ginormous database. Microservices world, you think about decentralizing your data. You basically have your service and your data close together, right? So by doing that, you can actually deploy a new service and its data schema independently from all the other services. So microservices interact with other services through known protocols, it's like HTTP and so on, have unique URLs, and then they should stay consistent and available. So Service Fabric has two types of microservices. And the first one is a stateless microservice. And this means like stateless, if you think about a compute or a calculator, that's a truly stateless app. But in general, when we talk about stateless services, it means you have your state stored somewhere in a database backend, or you have it like in a cache or anything like that. So, but your service itself is kind of stateless, so they can scale out and in. It can have multiple instances. So what you can build with those stateless services are basically web front ends. It's not different than today. Protocol gateways, or cloud services. And then the biggest difference there is for Service Fabric, we have a stateful service, and that's a true stateful service. It doesn't mean the data is in a database. It doesn't mean the data is in a cache. If you build a Service Fabric stateful service, the data is literally on the machine the service lives. And it has a hard authoritative state because we use replication mechanisms under the cover to make sure the data is always replicated from primaries to secondaries. And as a result, if your service goes down, it doesn't lose the state, right? Because it just fails over to another service with a secondary. So you can build multiple services on that. Databases, documents, workflows, user profiles are good examples for that. So Azure Service Fabric, what it really is a platform for reliable hyperscale microservice-based applications. So at the very bottom it runs in Azure, obviously, and I mentioned that up front. It runs on a private cloud like Azure Stack or in any other cloud, because we also give you not just a nice Azure service, but we also give you an installer. So you could basically set up your cluster anywhere. So at the foundational level where it says Service Fabric, what it does is, when you install Service Fabric, first and foremost, it sets up a cluster for you. It's a first-class orchestrator. It does resource balancing. It basically does everything you need to do in a distributed computing system, right? So let's go completely crazy and say, okay, I have like a bunch of microservices built and they're spread across my cluster, right? And now I create a hotspot because one of those services gets so much traffic. Service Fabric will notice that service or that particular node is under so much pressure, and it will place that service onto another node that has more resources available. So it's, in its core, it's also a cluster management and orchestration engine. What it also provides is no downtime upgrades. So very important in a microservices world is that you can roll out a new version of a microservice without taking down the old one, right? So it should be a no downtime upgrade. And if anything goes wrong during that update cycle, you actually want to roll back. And that's what Service Fabric gives you out of the box. And then on top of it, it offers you stateful and stateless services. Time permitting. So Service Fabric, services built with Service Fabric, I mentioned it yesterday. It's not something we just build, right? Because microservices is a trend, right? Everybody talks about microservices. So Service Fabric has been around for a lot of years, and our largest internal services have been using them. So for example, Azure SQL Database, our database offering in Azure, is built on Service Fabric stateful services. So it's a proven technology, and again, our internal services are using it. So it's a truly hyperscale app. So we have been running a preview program since build. And just to give you an idea how successful this has been is we have over 300 very named customers that have been working with Service Fabric and building applications already on Service Fabric. So those are just a bunch of them. So Service Fabric cluster, and I'm going to show you this, what that means is a Service Fabric cluster, just like a Mesos cluster, is a collection of virtual machines, except you don't need a zookeeper, right? So you don't need a leader election. We have it built in. It's already built in there. So you create a Service Fabric cluster, and leader election, everything is in there. So then if you deploy your services on the cluster, they're distributed amongst the cluster based on availability. You could also set resource constraints and say, I want to pair those services. They should always stay together, and so on and so forth. And then in a case of a machine failure, let's say your node goes down, you won't lose those services. What Service Fabric does is it places those services immediately onto other nodes. So your service stays available all the time. And let me show you how that works. So let's go in here. So this is a word count, and I started it a while ago. It's counting just words, right? And it's basically a stateful Service Fabric. It's a stateful Service Fabric service. And let's go in here and look at it quickly. Oh, hang on. All right. So this is our cluster explorer that comes with Service Fabric, and it basically shows you it. So I have 5 nodes that's deployed to Azure. I have 5 nodes, which means I have 5 virtual machines. My applications in there running is word count. And word count has a front-end service. That's basically the website you see, right? It's a stateless front-end service. And it has a back-end service because something needs to keep the state for counting the words, right? And the back-end service is this word count service, which is built as a stateful service in Service Fabric. And if I look at the service itself, you see that it basically spreads around, like it partitions the service. It has a primary, which runs on node 2, and it has a bunch of active secondaries, right? So now the traffic from that web service actually goes to node 2. But what happens if I shut down node 2? Let's go in here and stop node 2, right? I just kill it, provoke a machine failure. Stop node 2. So now my primary is not there anymore, and let's go there. Look at the time, or look at the count here. You can see it just continues counting. It just fails over, right? So what that means is you're not losing your state. Right? Your state is preserved in primaries and secondaries. If one node goes down, if there is a failure, your service will just continue with that state where it was, and it's very easy to develop. It's super easy because we have a thing it's called in .NET reliable collections. For every developer, he can just use or she can just use collections, a collection type, which is just like any .NET collection. The difference is that our collection is a reliable collection and actually writes it to primary and secondaries. So that's the one demo. The other demo I wanted to quickly show you, I'm running out of time here, is if I go to this one, that's the virtual objects demo that's based on an actor model. So in here, every square is an actor, right? So what I want to do is, let's say I want to upgrade that service and keep that service alive. Microservices concept. So here's the code for it. And what I'm going to do here is I'm going to make a code change to the service, and I say, you know what? I also want those things to rotate, right? So now, this is Service Fabric in Visual Studio. Now I made the change, and what I'm going to do now is I say publish. Here I'm going to run it on my local box, which is exactly the same. It's not an emulator. It's the same bits that run in the cloud. But I'm going to say I want to upgrade the application. And I'm going to create a new version for it. But I only touch the actor service. I don't want to update the web service, right? So I'm going to touch the actor service. I'm going to do this. And hit save. And then I'm going to start publish. So what's happening now is, if I'm going to go in here, I have the same cluster, a nice cluster management here, manage local cluster. Okay, I thought I had it. Okay, all right, let's look at this one. So what it does is it actually started the upgrade, and if I go back, it starts registering the type. So once it starts the update, the cluster manager would have shown you how it walks the update domains. But now you should slowly see those things start rotate as well and not just like go up and down. So let's see here. And so basically here I have an output. It says it started the upgrade, waiting for upgrade. Like this one. Yeah, problem is I should have done it in the cloud. Now all right, that's probably not a good example because I think my laptop's dying now. So. But what you would have seen is it basically starts rotating those actors instead of, while others are still going like diagonally, others start rotating. That's what you would have seen. But it looks like I'm having some trouble here locally. Yes, I cannot even open it. Okay, let's skip that. So bottom line is, takeaway here is you can update those services independently, which is true. Believe me, we have tons of demos that do that. The other takeaway is the development environment on your machine is exactly the same that we have in Azure. It just, oh yeah, now you can see, I think it starts, right? It's probably, the problem with that is I'm running like Service Fabric now on my laptop, and I think it's running out of resources. I have a lot of Chrome things open and Service Fabric. But you get the idea, right? It's working. So the other thing about Service Fabric I want to mention is it's going to be, right now, it's in preview, public preview. It's available on Windows, but we're going to make it available on Linux as well next year. So you will get exactly the same thing on Linux. And if you want to play around with Service Fabric, we even have something really cool here. And now my machine's really dying, which we call it a party cluster. So you don't have to pay. You don't need an Azure subscription or anything like that. So we have built a party cluster, which is built on Service Fabric. You download the SDK, and then you can basically say, hey, I want a party, and I think we limited it to 2 hours. And then you basically go there, say party now, and I think we only want your email address, and then you start playing around with it with Service Fabric. Okay, so with that, I know it was a lot to cover in like 50 minutes. I hope you have a better understanding or a good understanding of like our compute stack Again, to recap, virtual machines, scale sets we released new, container service released new, and Service Fabric. All great platforms for developers. And everything like works on Linux except Service Fabric, which will work on Linux, but everything is equally available on Linux as well as Windows. So with that, thanks for your time. Hope you enjoyed it. Yeah. Sorry for running out of time.